When historians speak about the Manhattan Project, they often focus on its scale, its scientific brilliance, and the unprecedented collaboration it required. But hidden behind the well-known milestones lies a story that is far more complex. A story of missing papers, unexplained gaps in documentation, uncertain authorship, and decisions that were never fully explained in public archives. The Manhattan Project wasn't just a scientific undertaking. It was an administrative labyrinth, a logistical giant, and a classified machine involving more than 130,000 people, most of whom never knew what they were really working on. Within this enormous structure, information flowed through narrow channels. Documents were duplicated, locked away, redacted, or destroyed, and entire departments operated in isolation from one another. That environment created something unusual, a paper trail that was both massive and incomplete. Some reports were filed under code names instead of authors. Some memos referenced earlier documents that no longer exist. Some notebooks from key researchers end abruptly, as if a chapter is missing. And some decisions, especially administrative and logistical ones, were recorded only partially, leaving historians with questions that were never officially answered. This is not a story of conspiracy, secrecy gone wrong, or missing revelations. It is a story about what happens when a project grows so large, so fast, and so confidential that even its own administrators cannot track every page created inside it. From the very beginning, the Manhattan Project relied on strict compartmentalization. Workers knew only what they needed to know. Scientists saw only fragments of the final goal. Engineers received blueprints missing key details. And record keepers were instructed to file, restrict, or destroy documents according to shifting instructions that often changed without notice. In some cases, the paperwork intentionally avoided specifics to prevent leaks, to reduce risk, or simply because the project evolved too quickly for formal documentation. Yet, when the 2020s brought renewed efforts to digitize and analyze historical archives, researchers noticed something intriguing. Certain parts of the project were less documented than others, not because the information was too sensitive, but because the administrative systems of the 1940s struggled to keep up with the speed and complexity of the work. For example, some procurement records reference materials whose destinations were never logged. Several internal memos mention experiments whose summaries are missing. Early drafts of reports cite datasets that no longer appear in the archives. Equipment lists from certain facilities skip serial numbers or omit entire batches. Notes from technical meetings end mid-sentence or without a conclusion. None of this suggests deliberate hiding. Instead, it reveals the difficulty of managing documentation for a project that expanded across dozens of sites, from coastal laboratories to remote desert facilities, each with its own filing system, clearance levels, and internal rules. The more historians looked, the clearer the pattern became. The Manhattan Project left behind a fragmented archive, enormous in scale, but uneven in detail. This fragmentation, combined with the natural loss of documents over time, created an aura of mystery around specific episodes, decisions, and individuals involved in the project. And that raises a compelling question, one that historians still debate today. What exactly happened to the documents that never made it into the official record? In the next part, we dive deeper into the origins of the Manhattan Project's documentation system and explore why some papers survived, why others disappeared, and how archivists today try to reconstruct a story that was never meant to be fully told. To understand why so many documents from the Manhattan Project are incomplete, missing, or strangely formatted, you have to picture the administrative world of the early 1940s. There were no digital backups, No automated indexing, no standardized federal archiving protocols for classified megaprojects. Everything depended on paper, typewriters, carbon copies, filing cabinets, and overworked clerks juggling thousands of pages a day. The Manhattan Project expanded at a pace far beyond anything the U.S. bureaucracy had ever experienced. Within months, new laboratories were built, supply lines created, contracts issued, and scientific teams assembled. Each site developed its own habits, its own filing systems, its own internal rules, because there was simply no time to harmonize procedures across the entire program. The result was predictable: a documentation structure that grew organically, unevenly, and sometimes chaotically. At headquarters, administrators attempted to enforce standardized forms. But out in the field, in remote desert bases, coastal research centers, university labs, industrial plants, the reality was different. Engineers needed to move fast. Scientists updated experiments daily. Contractors made last-minute changes. And every change produced a document that needed to be cataloged, secured, and stored. Not all of them made it. Archived memos from administrative offices described the struggle openly. Secretaries overwhelmed by constant revisions, technical notes arriving faster than they could be sorted, urgent communications written temporarily and never retyped. Duplicate copies stored in different locations, some of which closed abruptly. Filing systems that changed mid-project, leaving older folders misaligned. When historians later examined these archives, they found mismatches everywhere. Not because someone tried to hide information, but because the project simply outpaced the capacity of its own record keepers. Compartmentalization added another layer of complexity. Each division kept its own files under its own security protocols. Some labs used numerical classification codes. Others used alphabetical markers. Others still adopted entirely unique systems, invented on the spot to solve internal organizational needs. Because many teams were unaware of what other groups were doing, they didn't coordinate their documentation. This meant that a report referenced in one office might be impossible to locate in another. A scientist's notebook could be filed under a facility name rather than the author's. Administrative memos might use project nicknames unknown to other departments. Technical diagrams might be stored with procurement documents rather than research notes. And then there was the issue of temporary records, the most fragile category of all. Many documents were designed to exist only briefly. Daily logs, shift reports, handwritten calculations, updates on construction progress. Some were discarded intentionally once they were no longer needed. Others survived only if someone happened to keep them in a miscellaneous folder. The most dramatic effect came from site closures. When certain Manhattan Project facilities shut down after 1945, administrators had to process mountains of paperwork in a short time. Some documents were transferred, others were copied, some were archived, and some, inevitably, were discarded because they were deemed non-essential, a subjective judgment that today leaves historians with lingering gaps. Not all losses were administrative. Paper deteriorates naturally, especially in humid environments. Basements flooded. Storage rooms were repurposed. Boxes were moved, mislabeled, or lost in transportation. In a few cases, archivists, decades later, opened crates only to find stacks of pages fused together by moisture or damaged by mold. These realities explain why the Manhattan Project's archival record feels like a puzzle with missing pieces. Not because of secrets, but because of logistics. Yet even with these gaps, a remarkable amount survived. Thousands of pages documenting scientific experiments. Procurement logs revealing the enormous industrial scale of the project. Memos from administrators wrestling with unprecedented challenges. letters from scientists debating ideas that would redefine physics, blueprints showing how facilities operated at peak capacity. Still, the question remains, how do historians rebuild the story when parts of it exist only in fragments? In the next part, we explore exactly that. The detective work required to reconstruct missing chapters from cross-references, personal letters, laboratory habits, and metadata that survived even when documents themselves did not. When researchers began examining Manhattan Project archives in detail, they quickly realized that understanding the missing documents required more than simply searching for them. The project had grown too fast, operated across too many locations, and produced too much paper for a perfect record to survive. So historians turned to an approach that resembled forensic work, piecing together clues from any surviving source, no matter how small. What makes this process fascinating is that almost every remaining document carries traces of another. A memo references a meeting. A notebook cites an experiment number. A procurement form lists a shipment to a facility. Even when the original files are missing, the echoes of their existence remain scattered across the archive. Historians use these indirect signs as guideposts. For example, scientists often wrote summaries that referenced datasets no longer present. These summaries allow researchers to infer what experiments were conducted, when they occurred, and who was involved. In some cases, the summaries are detailed enough to reconstruct entire sequences of events, even if the original logs are gone. Personal correspondence is another key resource. Letters between researchers, administrators, or collaborators often reveal which documents were distributed, which reports were planned, which experiments required follow-up, what drafts were circulating internally. These letters sometimes mention papers that no longer exist in official archives. A reminder that many documents were once commonplace in laboratories before being lost or discarded. Another method involves reviewing facility workflows. Every Manhattan Project site had its own procedures for tagging, labeling, or storing information. By studying these systems, historians can reconstruct which papers would have been created and where they should have been filed. This allows researchers to map out document families, clusters of files that belong together, even if some pieces are missing. When a report references "see attached drawing," but the drawing is gone, archivists search procurement logs for materials that match the description. When a meeting summary mentions a previous memo, but the memo is missing, researchers look for copies in other offices that might have stored duplicates. These small clues accumulate and become a useful substitute for documents that vanished decades ago. Cross-site comparison also plays a crucial role. Because different facilities sometimes received copies of the same reports, missing pages from one archive may survive in another location. Researchers have discovered duplicate fragments in university collections, private estates, federal repositories, and even in boxes mislabeled during building relocations. In some cases, intact documents were found in places no one expected, stored with unrelated paperwork, because a secretary reused folders or a technician filed items by project nickname instead of official number codes. Even seemingly trivial materials help. Receipt books, toolroom logs, visitor lists, maintenance cards, all these minor sources provide context that fills gaps left by missing scientific documents. They reveal when equipment arrived, who accessed it, and how laboratories functioned day to day. Another technique involves analyzing the rhythm of scientific work. Physicists and engineers typically worked in predictable cycles: test, measure, revise, repeat. If documentation exists for steps 1 and 3, but not step 2, researchers can often interpolate the missing part with surprising accuracy. The internal logic of scientific routines becomes a roadmap. What's striking is how much can be reconstructed without recovering a single lost document. Patterns emerge, timelines sharpen, motivations become clearer. Technical decisions gain context. The result is not a perfect record, but a highly reliable one, built not from speculation, but from cross-referenced evidence. Yet some questions remain unresolved. There are instances where the paper trail simply ends, where a document is referenced repeatedly, but has never surfaced. These gaps are not unusual for a project of this size, but they continue to intrigue historians because they reflect the limits of reconstruction. Still, the work continues, and with ongoing digitization, new archives opening, and families donating private papers, the historical mosaic grows more complete each year. In the next part, we look at a different source of missing material, documents deliberately restricted or redacted during the project, not because of their scientific content, but because of administrative necessity and security protocols that shaped what could be written, copied, or preserved. As the Manhattan Project expanded across the United States, one rule governed every laboratory, every office, every contractor, and every scientist. Write down only what is necessary and nothing more. This principle, simple on the surface, had enormous consequences for how the project was documented. It shaped which files survived, which were redacted, and which never existed in the first place. Security wasn't merely a guideline. It was a structural force shaping the entire administrative culture. Every employee signed confidentiality agreements. Every page carried classification markings. Every copy had to be tracked. Every memo had to be approved before it could be circulated. In this environment, silence became part of the workflow. Researchers often avoided writing sensitive details, not because of any mystery, but because written material could be copied, misplaced, or read by someone without clearance. Administrators created layers of reporting that filtered out specifics. Technical discussions were sometimes kept entirely oral, recorded only in the memories of those present. Even when something had to be documented, the format wasn't always straightforward. Many reports were written in segmented style. A version for internal use, a version for administrators, a version stripped of details for circulation between sites. The reduced versions often replaced specifics with general statements, leaving later historians puzzled by references to standard procedures or previously agreed adjustments, despite no surviving record of what those terms meant. Another factor was the copy limitation rule. For many documents, only 2 or 3 copies were allowed. One stayed at the site where it was written. One went to central administration. And sometimes a third remained with the author or project lead. If even one of these was misplaced, destroyed, or misfiled, the record became incomplete forever. Redaction also shaped the archive. Certain administrative documents were stripped of names, dates, or descriptions before being stored, especially if they mentioned personnel assignments, procurement origins, or inter-site coordination. These redactions weren't about hiding scientific knowledge. They were about protecting logistics, supply chains, and organizational structures. It was common for files to contain entire paragraphs replaced with short notes like "section removed due to security classification," or simply "content restricted." To modern researchers, these gaps can look mysterious, but at the time, they were routine. Another structural cause of missing documents came from the need to know restriction. If a scientist didn't require a report to perform their work, they never saw it, and therefore never stored a personal copy. This meant that many papers existed only in the office of the small administrative group responsible for handling classified materials. When those offices later closed or reorganized, their files were vulnerable to consolidation errors. In addition to administrative policies, the urgency of wartime operations shaped documentation practices. Offices weren't designed for long-term record preservation. They were designed to keep the project functioning day to day. When deadlines were tight and decisions urgent, documentation sometimes took second priority. Clerks typed as quickly as they could. Scientists scribbled notes on scrap paper. Some materials were labeled temporary and never archived. And yet, the same security systems that restricted paperwork also ensured that a surprising amount survived. Every classified document had to be logged. Every page was numbered. Every storage room had inventories. Every transfer required signatures. When modern historians reconstruct the project, they often rely on these surviving administrative traces: check-in logs, storage records, destruction orders, and movement sheets. Even if the documents themselves disappeared, the paperwork around those documents sometimes remained. This makes the Manhattan Project archive an unusual combination: massive, fragmented, and meticulously structured, all at the same time. The more researchers study it, the clearer a pattern emerges. The gaps aren't the result of hidden events or withheld revelations. They are the natural consequence of a system that treated documentation as both essential and dangerous. In the next part, we shift the focus toward a different category of missing material: the documents that disappeared not because of secrecy, but because of scale, human limitations, and the fragile nature of paper itself. For all its scientific brilliance, the Manhattan Project depended on something remarkably fragile: paper. Not digital backups, not microfilm archives, just ink, carbon copies, onion skin sheets, and handwritten notebooks, stored in metal cabinets, wooden drawers, or simple cardboard boxes. For a project of unprecedented size, this created a fundamental challenge. Paper bends, tears, smears, warps, fades, and, worst of all, gets misplaced. Many of the missing documents traced by historians fall into this very ordinary category: materials that were never meant to survive 8 decades, not because they were classified, but because they were physically vulnerable in ways modern projects no longer face. Across different Manhattan Project sites, clerks and engineers dealt with real-world limits every single day. Humidity-swollen files, pages stuck together by heat or moisture, cabinets overloaded to the point of bending, drawers jammed from constant use, ink fading on cheap wartime paper, handwritten notes becoming unreadable after a spill. This kind of loss wasn't dramatic, it was inevitable. Paper from the 1940s was not archival quality. Many pages were printed on low-cost pulp stock due to wartime rationing. Some documents were typed on carbon paper so thin that copies faded within months. Handwritten notes on scrap sheets were easily torn or discarded. Even simple exposure to sunlight or fluctuating temperatures inside makeshift offices could degrade documents faster than anyone realized. Then there is the logistical side. The Manhattan Project operated in dozens of locations: university labs, temporary offices, industrial plants, military bases, and remote research zones. Each site had its own storage conditions, some ideal, others improvised. When files were moved from one building to another, mislabeling was common. Boxes were repacked, resorted, or reshelved so many times that original structures dissolved. Archivists later found records of boxes transported during building renovations and never returned, folders mislabeled after hurried reorganization, mixed documents from different departments stuffed into the same container, inventory sheets that referenced shelves no longer in existence, misfiled items placed in the wrong alphabetical or numerical group. None of this implies secrecy. It is the normal wear and tear of a massive, overloaded system. Another source of loss was simple human limitation. Tens of thousands of people worked in environments where pressure was constant and speed was essential. Under those conditions, clerks accidentally mistyped document numbers, technicians misplaced lab logs after shift changes. Researchers borrowed files and forgot to return them. Contractors used blueprint sheets as scratch paper. Notebooks were carried from lab to lab and abandoned. The archival footprints of such mistakes remain visible today. Even more striking is the impact of site closures after 1945. When wartime operations wound down, entire buildings shut within weeks. Offices had to be cleaned out quickly. Some administrators kept what seemed important and disposed of what looked routine. Boxes were consolidated, stacked, shipped, and sometimes lost in transit. These decisions were practical at the time. No one imagined that future historians would hunt for every memo and marginal note. Floods, leaks, and fires also played a role. At several facilities, storage areas suffered water damage in the decades after the war. Archivists later opened boxes to find pages stuck together, ink bled across sheets, or whole sections hardened into unusable blocks. Pest damage, mold, and simple aging destroyed other materials. Ironically, some of the best preserved documents survived not because of intentional care, but because someone forgot them in a sealed cabinet that remained undisturbed for 40 years. The patterns are clear. The archive is incomplete, not because of mystery, but because paper was never designed to hold the weight of a project of this magnitude. And yet, despite these losses, the surviving materials form one of the most detailed scientific archives of the 20th century. The gaps are real, but the core remains remarkably strong, thanks to redundancy across different sites and the sheer volume of what was stored. In the next part, we turn to a compelling category of missing records: the personal notes, diaries, marginalia, and informal writings of scientists. Materials that were never part of the official archive, but which offered insights into the human side of the Manhattan Project. If there is one category of Manhattan Project documents that fascinates historians more than any other, it is the one that barely survived, or never officially existed. These are not classified reports or redacted memos. They are the personal notes of scientists, the pocket diaries of engineers, the scratch calculations on the back of envelopes, and the margin annotations on drafts that reveal thinking in real time. They are the documents that show the human side of a massive, impersonal project. But many of them were never archived, never copied, and never intended for long-term preservation. In scientific environments, especially during the 1940s, researchers often relied heavily on handwritten notes. Full reports were typed only after results were stable. Before that, work progressed in rough sketches, equations scribbled on cafeteria napkins, preliminary graphs on cheap graph paper, hurried calculations in notebooks already half-filled, comments written sideways along the margins, half-finished sentences left open for the next day. This kind of material was the lifeblood of scientific creativity, but administratively it occupied an awkward position. It was essential for immediate work, but rarely considered official. It was private, personal, and unfiltered. And because of that, it was also expendable. Many scientists threw away early drafts once they completed formal reports. Some burned old notebooks out of habit, a common practice in labs at the time. Others left notes scattered in desk drawers that were emptied quickly when facilities closed. In some cases, researchers carried notebooks home, where they stayed for decades before being rediscovered, if they survived at all. Even when personal notes were preserved, they weren't always easy to identify. Archivists examining collections from the 1960s and 1970s found papers stored in unmarked boxes, bundled with unrelated documents, or misfiled under administrative categories that had nothing to do with research. Then there is the issue of personal discretion. Many scientists believed that drafts were not meant for others to read. They removed pages containing rough or incomplete thoughts before submitting final versions of reports. In an environment defined by secrecy and compartmentalization, researchers often protected their own working ideas, not out of security concerns, but simply because they didn't consider preliminary work part of the historical record. This created an unexpected dynamic. A significant portion of early scientific reasoning existed only in fragile, unofficial forms, and disappeared as quickly as it was created. But some traces survived in indirect ways. Colleagues referenced conversations in letters. Administrators summarized informal meetings in official memos. Drafts retained faint impressions from removed pages. Notebook margins hinted at discussions never fully documented. These fragments help historians reconstruct the intellectual atmosphere of the project, the debates, the hesitations, the bursts of insight that shaped decisions. What makes this category particularly intriguing is that personal notes often reveal context missing from formal documents. Where official reports present results, personal materials show the process, the uncertainty, the trial and error, the disagreements that were later smoothed out in final drafts. But as with so many aspects of the Manhattan Project, only pieces remain. Some scientists kept every notebook, others destroyed everything after publication. Some collections were donated to universities, others stayed in family archives until descendants rediscovered them years later. A few were lost forever when offices were cleared or houses were sold. These inconsistencies explain why historians sometimes encounter sudden jumps in the documentary record. Places where the official narrative moves from one conclusion to the next without revealing how the team reached that point. The absence is not mysterious. It reflects the natural rhythm of scientific work, amplified by wartime pressures. Nowhere is this clearer than in the personal diaries of project members. Many wrote impressions of daily life, logistical frustrations, or observations about working conditions, but even these were often intentionally vague. People living under strict confidentiality rarely recorded sensitive details, even privately. And when the war ended, many such diaries were treated as personal items, not historical documents. Families stored them, moved them, or discarded them unknowingly. Today, historians treat every surviving personal notebook as a treasure, not because it contains hidden secrets, but because it reveals how innovation looks before it becomes history. In the next part, we turn to a different but equally important dimension: the documents that were intentionally destroyed after the project ended, not for secrecy, but for administrative efficiency and space management. In the years immediately following the end of the Manhattan Project, the United States faced an enormous administrative challenge: what to do with the mountains of paper that had accumulated across dozens of facilities. Laboratories had been built rapidly, offices expanded, temporary storage rooms filled, and filing cabinets stuffed with everything from engineering drafts to cafeteria schedules. When the war ended, many of these facilities were downsized or closed altogether. Space was limited, budgets were cut, and the government had to decide which documents to safeguard, which to store, and which to destroy. The key point is simple. Not everything generated by the Manhattan Project was considered worth preserving. In fact, the majority of paperwork was never intended for long-term archival storage. Wartime operations produced enormous volumes of routine documentation: daily shift logs, minor procurement receipts, repetitive production reports, early experimental drafts later replaced by final versions, memos regarding temporary procedures, construction updates and equipment checklists. To administrators in 1946 or 1947, these were not historical treasures. They were everyday operational documents, useful during the war, unnecessary afterward. Thus began the process known as post-project reduction, a standard federal procedure. Teams were assigned to review boxes, drawer by drawer, folder by folder, deciding what stayed and what went. Their mandate was clear: keep what is essential to the scientific and administrative record. Remove anything considered redundant or routine. This wasn't about secrecy, it was about practicality. Warehouses were expensive, archival preservation was difficult, and nobody imagined that historians, decades later, would want to reconstruct every detail of the project. Records from these reduction teams reveal a structured system. Duplicates were shredded, outdated drafts were discarded, early versions of reports were removed, temporary notes were eliminated, non-critical correspondence was destroyed, paperwork with unclear authorship was not preserved. Sometimes entire categories of documents were marked administratively obsolete, meaning they had fulfilled their purpose and were no longer needed. In some cases, the guidelines were broad, leaving decisions to individual clerks. That meant two different offices could treat similar files in different ways. Some preserved, others discarded. This explains why randomness appears in the surviving archive. A laboratory in one state might save early sketches, while a facility in another considered them irrelevant. A secretary might keep an engineer's notebook because it looked important, while a different office tossed similar notebooks into burn bins. The same process occurred with duplicated materials. If a central office already stored a copy, satellite sites were instructed to remove their local duplicates. When facilities closed, their documents were shipped out, but not always completely. Sometimes boxes labeled as empty were burned without being inspected thoroughly. Other times, documents were misclassified and accidentally destroyed. There were also practical issues. Storage basements flooded, outdoor temporary huts collapsed, and warehouses suffered environmental damage. Some documents simply decayed before anyone had the chance to review them. These procedures were not unique to the Manhattan Project. Every large wartime project of the era faced similar reductions, but because the Manhattan Project was so vast, the effect on its archive is especially visible. For modern historians, the result is a complex picture. Some files survive in pristine condition. Others exist only as references in surviving memos. Some categories disappeared entirely, leaving only hints of what they once contained. Yet despite the losses, the project's core remains remarkably well documented. Its scientists, administrators, and engineers left behind thousands of pages that continue to be analyzed today. What vanished were mostly peripheral materials, but their absence adds a sense of depth to the historical record. In the next part, we explore one final factor behind the missing documents: the relocation of materials in the decades after the project, when archives were moved, consolidated, split, donated, or simply misfiled as institutions reorganized. Long after the laboratories went silent and the temporary wartime offices were dismantled, the documents of the Manhattan Project continued to move, sometimes intentionally, sometimes accidentally, and sometimes without anyone fully recording where they went. It is one of the least dramatic, but most influential reasons for today's archival gaps. During the 1950s, 60s, and 70s, various agencies assumed responsibility for portions of the original project records. Some materials were transferred to federal research institutions. Others went to military archives. Universities absorbed documents from individual scientists. Private companies retained records related to their roles as contractors. Families inherited personal papers. Over the decades, this created an enormous, scattered puzzle of storage sites. Every move introduced new opportunities for misfiling, loss, and fragmentation. The first major wave of relocation happened when wartime facilities were repurposed. Buildings once filled with classified material became ordinary research centers or administrative spaces. During these transitions, boxes were consolidated for convenience, labels were rewritten or simplified, damaged folders were replaced with new ones. Older storage logs weren't always updated. When archivists decades later tried to match descriptions to physical files, they often discovered that document codes no longer aligned with their original locations. What had once been a tightly controlled classification system became layered with years of revisions, shorthand notes, and reorganization. A second wave of relocation came when the federal government reassigned oversight of scientific archives. Different agencies used different filing standards. Some preferred chronological systems. Others used project-based groupings. When Manhattan-era documents entered these new systems, they were absorbed into broader categories, sometimes losing their original context. For example, a technical memo might end up in an engineering general file. A meeting summary might be placed under administrative correspondence. A scientist's notebook might be stored as part of a personal collection. Procurement lists could be merged into later budget archives. Such reclassification didn't destroy information, but it made it harder to trace. Historians searching for a paper referenced in 1944 might find it filed in an unrelated 1950s category, simply because an archivist decades earlier made a reasonable but context-light decision. University collections present another case. After the war, many Manhattan Project scientists returned to academic life. They brought papers with them: drafts, notebooks, letters, data sheets. These materials were often stored privately until retirement or passed down through estates. When finally donated to libraries, they were cataloged according to university archival rules, not federal ones. This produced fascinating but uneven results. One professor's papers might be meticulously organized, another's mixed with unrelated correspondence, a third's partially lost before donation. Some collections included valuable fragments of missing documents. Others contained only references to materials that no longer existed. Private companies that worked as contractors added yet another layer. Many kept internal records for legal or administrative reasons, but not all preserved them long-term. When businesses merged, reorganized, or closed, their archives were absorbed into new corporate structures. Some were donated, others discarded. Occasionally, archivists stumbled upon forgotten boxes decades later, containing materials thought lost. Even museums and historical societies unintentionally contributed to document drift. Exhibitions often required borrowing items from archives. After displays ended, materials were returned, but sometimes placed in new folders or drawers for convenience, not in their original positions. All of this movement created a phenomenon historians call archive migration. Documents were not destroyed, they traveled. And in moving, they lost the connections that once tied them to other files. The most striking examples involve mislabeled boxes. Archivists occasionally discover crates bearing vague descriptions like Miskeen reports or old correspondence. Inside, they sometimes find Manhattan-era items, misfiled decades earlier. In other cases, researchers encounter folders with documents swapped between sites, their covers marked by multiple generations of handwriting. This explains why studying the Manhattan Project today remains a continuous, evolving effort. As archives are digitized, reorganized, and re-examined, pieces of the puzzle reappear, not because they were hidden, but because they were displaced by the momentum of decades of administrative change. And with every recovered fragment, the story becomes clearer. In the next part, we examine the lingering questions. Why do some gaps persist? What can realistically be reconstructed? And how do historians separate myth from meticulous archival reality? After decades of research, digitization, and archival reconstruction, the Manhattan Project is one of the most documented scientific efforts of the 20th century. And yet, certain questions linger. Not because someone hid information, and not because dramatic secrets lie buried underground, but because the historical record has natural limits. The gaps that remain are shaped by the same forces that shaped the surviving archive: the project's size, its speed, its secrecy, its paperwork habits, and the normal erosion of time. The first category of unanswered questions comes from documents that were described but never found. Historians sometimes encounter references to reports that seem important, but have no surviving copies. A memo might say, "See detailed analysis" in the attached study, but the study itself is missing. In these cases, it is nearly impossible to know whether the missing document was a brief calculation, a lost draft, or something that never progressed beyond an outline. Another type of uncertainty involves project decisions recorded only partially. Some administrative actions were approved informally or discussed verbally, with only small procedural notes entering the written record. When these decisions influenced later work, historians see the effect, but not always the original reasoning behind it. A third category involves the rhythm of scientific work. Preliminary results, early hypotheses, and intermediate steps often lived only in personal notes or informal lab conversations. When those materials disappeared, the logic connecting early ideas to final conclusions became harder to trace. The science itself is well understood, but the internal decision paths sometimes remain blurred. There are also unresolved questions connected to timing. The Manhattan Project moved so quickly that documentation frequently lagged behind reality. By the time a report was typed, the experiment had already changed. When the final version was saved, earlier iterations were sometimes discarded, leaving behind sudden jumps in the written narrative. But perhaps the most persistent uncertainties come from interpersonal communication. Scientists debated constantly, in hallways, over meals, during lab breaks. These discussions were essential for scientific progress, but they were rarely documented. The absence of these informal exchanges means historians will never fully reconstruct how certain ideas were shaped, refined, or challenged. And yet, while the gaps remain, the myths that sometimes arise around them rarely match the reality. The missing materials are not evidence of hidden breakthroughs or undisclosed discoveries. They are evidence of a giant project operating beyond the limits of 1940s documentation capabilities. Historians consistently find that missing reports were usually drafts replaced by final versions. Lost memos were administrative, not scientific. Unavailable notebooks were personal, not program-defining. Absent pages reflected ordinary clerical constraints. Destroyed files were categorized as redundant or temporary. With each new archival discovery, a box in a basement, a folder in a family estate, a misfiled notebook in a university collection, the broader picture becomes clearer. The gaps are exceptions, not patterns. Modern scholarship has reached a stable consensus. The Manhattan Project's core scientific and administrative story is complete enough to understand the full shape of the project. What is missing are details, nuances, and small contextual threads, valuable for historians, but not transformative for the overall narrative. Even so, the unanswered questions remind us that history is never perfect. It is reconstructed, interpreted, cross-referenced, and sometimes inferred through careful study of surviving fragments. They also remind us that behind every large historical archive lies a human process, vulnerable to time, pressure, miscommunication, and chance. In a way, the gaps themselves are part of the story, a testament to the speed, complexity, and unprecedented scale of a project built under extraordinary circumstances. In the final part, we bring the entire documentary together, showing what the missing documents truly tell us about the Manhattan Project and why, despite every loss, the historical record remains remarkably strong. Looking back at the Manhattan Project through the lens of missing files, fragmented notes, and faded paperwork, it becomes clear that the gaps in the archive are not signs of hidden revelations. They are signs of scale. They reveal how enormous, improvised, and fragile the administrative machinery behind the project truly was. If anything, the missing pages tell us more about the limits of human organization than about the science itself. The Manhattan Project grew faster than any record-keeping system could. Entire laboratories were built before filing rooms existed. Teams expanded before clerks could label folders. Experiments changed direction before memos could be typed. Offices closed before anyone finished sorting their documents. The gaps in the archive reflect this constant acceleration. They show the reality of a project where people carried notebooks from lab to lab. Drafts were rewritten multiple times. Copies were restricted to avoid leaks. Temporary notes were discarded daily. Departments worked in isolation. Storage spaces were improvised. Boxes moved from site to site. Files were reorganized repeatedly over the decades. In this way, the missing pages become part of the historical narrative, not a mystery to be solved, but evidence of the human factors shaping a project too large for perfect documentation. They show us how wartime urgency affects paperwork, how secrecy reshapes communication, how administrators prioritize survival of essential material over completeness, how ordinary mistakes, aging paper, and shifting facilities shape what reaches the future. But even with these gaps, the Manhattan Project remains one of the most thoroughly documented scientific enterprises in modern history. We know who led each research division, how the administration was structured, which decisions shaped the project's progress, how laboratories coordinated, how materials were procured, how facilities operated, how scientists communicated, how results were tested, reviewed, and revised. We also know how the project's culture worked: the pressure, the compartmentalization, the intense collaboration, and the constant adaptation to new challenges. In fact, the surviving archive is so large that historians continue discovering new insights even today. Boxes long forgotten in storage rooms are digitized. Personal collections from scientists' families are donated. Mislabeled folders in university basements are finally cataloged. Each discovery adds texture, but rarely changes the big picture. That big picture is remarkably stable. The Manhattan Project succeeded, not because every document survived, but because enough of them did. Enough to understand the decisions, the processes, the structure, the goals, the obstacles, and the human dynamics that defined the effort. The missing pages don't undermine the historical record. They remind us that no project of this size could ever preserve every detail. And they highlight something deeper. History is not a perfect archive of everything that happened. History is the story reconstructed from what the world managed to save. In the case of the Manhattan Project, what the world saved is extraordinary. A mosaic of science, administration, personal struggle, and national urgency, preserved across decades despite every obstacle. The gaps are real, but what remains is more than enough to understand the truth. And in the end, the missing documents do not obscure the story. They illuminate the human imperfections behind one of the most complex achievements of the 20th century.